we can use only 6 diodes. Okay, so if we use a and the load will be connected with the system in this fashion. So this is a basic circuit diagram of a three-phase inverter. So do you have any question regarding this circuit? It is almost similar to the three-phase rectifier. In a three-phase rectifier, we actually give the input through the point A, B, and C. But here we actually get the output from the point A, B, and C. So the DC source gives a different, using the DC source in V in, we can get the output. So similar with the rectifier circuit, it has a one upper bank and a lower bank. So in the upper bank circuit, there are 3 switches. In the lower bank side, there are 3 switches. Up to this point, is it okay with you?
Yes, sir.
Okay. So if it is okay with you, then we can proceed. Why there are 3 switches? Why? What is the switch condition and the angles and other things? We can now proceed with those points. Okay. Since it is a 3-phase, so it requires 6 switches. Why? Why? It should be S. Not good. 6 switches. Sorry, my S is a little bit. 6 switches. 1 for upper positive sine wave, positive part. Not for one is for positive part, and the other is for negative part of the voltage. So 2 switches for each wave. For each wave. Since it is 3-phase, then 2 into 3 means 6 switches are required. So if it is 4-phase, then it will require 8 switches. If it is 5-phase, then it will require 10 switches. Okay. 4 and 5 actually hypothetically we are thinking. We usually do not commercially, these things are not available, but we can think in a hypothetical way. Okay. Do you have any question up to this point? Why we are using 6 switches? I think it's simple to understand. Then we have to think about the other parts. How we can draw the output waveshapes, how we can manage those switches. Okay. So I'll go to the next point. we have 6 switches. So 360 degree is a cycle. So if we divide 360 degree divided by 6, then it is 60 degree. So when switch 1 has started, switch 2 will start from here. We can see that this is, we'll explain it more elaborately later. We've just started. So here switch 1 is like this, 180 degree is actually the conduction, and if it is 180 degree, there are 3 blocks. You can see it. Can you see this point? For 180 there are 3 blocks, here, here, here. Okay, so using this idea, so this is 60 degree apart, this is 120 degree, and this is 180 degree. Is it understandable? Can you understand this point?
Yes, sir.
Yes, sir.
Okay, so the second switch, switch 2 will start from after 60 degree, and the third switch will start from again after 60 degree of the first switch. Okay, so let's think about the switching diagram first. This is the basic idea I'm giving you. So if we draw the switching diagram of a 3-phase inverter, how it will look? Okay, now please try to draw the diagram with me and make necessary notes. Switch 1. Here usually we denote a switch with Q or S. You will find Q or S in this one. So switch 2, switch 3, switch 4, switch 5, and switch 6. Okay, so we need to think about one part, that is switch 1, it will conduct for 180 degree, switch 2 will also conduct for 180 degree, switch 3 also for 180 degree, switch 4 is 180 degree, switch 5 180 degree, and switch 6 180 degree. Okay, so here we are calling this the conduction is at 180 degree for all. It should be like this. If the conduction is 120 degree, then 120 degree for all, and the others will remain off. So if switch 1 will conduct for 180 degree, we need to think about this diagram. So I am just drawing the circuit diagram again in the side of this for your clarity. So you find a different thing. For example, if we write the diagram in here, okay, is there any problem? Can you understand? I have just drawn the circuit diagram again so that you can check. So if you find the circuit diagram, we cannot switch on 1 and 4 at the same time. Can you understand this point?
Sorry, sir. Can you repeat once more?
Yes. From the circuit diagram, we can see that we cannot switch on switch 1 and switch 4 at the same time. What will happen then? We cannot switch on 3 and 6 at the same time. And we cannot switch on 5 and 2 at the same time. Do you understand what will happen if we do so?
It will become short, sir.
They'll create a short path.
Yes. So actually 1 and 4 must be in invert logic. 3 and 6 must be in invert logic. 5 and 2 must be in invert logic. Okay. So first we are considering that first 180 degree will conduct from switch 1, then the next 180 degree will be conduct from switch 4. Okay, so 1 and 4 must be in invert logic, and 3 and 6, and 4 and 5, sorry, 5 and 2. Okay, so if we draw the conduction of switch 1, we have to know about the conduction of each switch. Here we call it conduction angle. Now the conduction, if the conduction angle is 180 degree, so we need to define that the switch is conducting up to this point. This is 180 degree. Okay, I am just denoting this part as a 180 degree. Okay, so next 180 degree will be for switch 4. So there will be a gap of 180 degree, and then again it will conduct. Okay, allocation, time allocation for Q1 is in this fashion. We can make the conduction angle lower, okay, but we cannot make the conduction angle more than 180 degree. Okay, this is allocated time for switch 1. Do you have any question regarding this part?
স্যার আমাদের কি এটা ফিক্স যে স্যার 6 ডিগ্রি থেকে হবে স্যার? আমরা যে 360 ডিগ্রি ডিভাইডেড বাই 6টা সুইচের জন্য 6 দিয়ে ভাগ করলাম স্যার এটা। এটা কি স্যার 60 ডিগ্রি থেকে হবে স্যার?
Which one?
আমরা প্রথম পেজে যেটা করছিলাম স্যার যে 360 ডিগ্রি ডিভাইডেড বাই 6টা সুইচ ডিভাইডেড বাই 6 স্যার। তো যে 60 ডিগ্রি আসছে এটা কি ফিক্সড স্যার আমাদের জন্য?
60 degree, yes.
জি স্যার।
It is it will help to define the mode size. So the switch 2 will on just after 60 degree and will conduct for 180 degree. Okay, so here you can see that switch 2 will on after 60 degree. Here actually 60 degree, the green circle, actually this is the 60 degree. So switch 3 will start from another 60 degree, just after another 60 degree from switch 2. So here actually, sorry, this is 120 degree. Okay, and it will stop here. Okay, and now switch 4 will start from here and will end at this point. So this is a gap of 180 degree, and it will start again in here, and switch 5 will start from here and switch 6 will start from here. So you can find one idea that every switch, actually here is a gap of 1, 2, 3, and there is also a gap of 1, 2, 3 for the next pulse. 1, 2, 3, again 1, 2, 3. So 1, 2, 3, right? Okay, so if we think like this, 3, 2, 1, so there should be a pulse in here. Okay, and there should be a pulse in 3, 2, 1. So the pulse will start from here. Okay, so if we take a good care of pulse 5 and 6, we can think about the pulse will also from here at the starting point. Is it okay with you?
Yes sir.
Okay, so now we'll look about the other things.
স্যার আমরা চাইলে তো স্যার ডান দিকেও দেখাতে পারবো স্যার।
Sure, from here.
Yes sir.
Okay, and from I'm not disturbing the circuit. In the 6 you can also
Okay sir.
because we will need that circuit. Next, you can see that there is a no overlap of 4 and 1. Can you see it with the blue line? There is a no overlap of Q4 and Q1. Okay, so whatever the conduction is, we have to start Q4 after 180 degree of Q1. after the allocated time of 180 after the allocated time of q1. Okay, why I have used that term allocated? The allocated okay, this is its allocation. Whether it is using it or not, we can define it later. If the conduction angle is 120 degrees, consider this term very carefully. If the conduction angle is 120 degree, then q1 will be like this. It will conduct for 120 degree. Okay, you can see the blue conduction. Please ignore the amplitude. You just ignore the amplitude of red one, and they will be same. Okay.
স্যার 120 ডিগ্রিতে কন্ডাকশন করবে কেন স্যার?
আমি যদি চাই, if I want to make the conduction lower, it requires sometimes you will get a different output for different conduction angle. Okay, and q4 will start from here. It will start from here and end in here. So in this zone, no one will be on. q1 will be off, q4 will be also off. q2 q3 may remain on, that's a different issue, but in this zone q1 and q4 both are on, off, they are not on. Okay, and in this point also. Okay, so the switch, if they are not on, you will find different things. Output voltage will be changed. Okay, do you have any question up to this point? If you do not give good concentration, it will be difficult for you in the exam to answer properly.
স্যার মাঝখানে যখন এই যে অফ থাকবে তখন স্যার তাহলে ওয়েভগুলো কিরকম হতে পারে স্যার?
We'll let you know one by one. First of all, we start with 180 degree conduction. If you I can understand this 180 degree conduction in a very good manner, then you can understand the 120 degree, and then you can make your own choice.
এটা কি স্যার অ্যামপ্লিটিউড গুলো ছোট করার জন্য করব নাকি?
The wave shape will also be changed. The output wave
জি
shape.
স্যার।
If the output wave shape change, then you will change the frequency spectrum also. Frequency spectrum will also be changed. And considering those frequency spectrum, we can consider the inverter quality.
ওকে স্যার।
Please try to draw with me. Okay, here we'll define a new term, mode size. Okay, what is the mode size? Actually, mode size is the minimum, the maximum allowable angle or the time of each point, each circuit condition actually. So here we used 6 switches, each switch with 60 degree, and we have 180 degree in conduction. So this is from conduction, and this 60 degree is from 3 phase, and this 60 degree is from 3 phase. And if we take GCM, then the size will be 60 degree. আমরা যদি 60 ডিগ্রি এবং 180 ডিগ্রির মধ্যে গসাগু করি তাহলে আমরা পাই 60 ডিগ্রি। সুতরাং এই 60 ডিগ্রিটা হচ্ছে আমার মোট সাইজ। This 60 degree is the mode size of this condition. For 180 degree condition, the mode size is actually 60 degree. If the conduction is 150 degree, then the mode size will be in this fashion. The mode size will be 30 degree. Is it okay with you?
Sir, বুঝিনি আরেকবার।
What part?
স্যার মোট সাইজের ওটা।
কার কোশ্চেন?
স্যার সজল।
I want to know one thing. What is the meaning of greater common factor? Or what is the meaning of like in Bengali? You are from Bengali medium or English medium?
স্যার বেঙ্গলি মিডিয়াম।
Okay, গসাগুর মানে কি?
লঘিষ্ঠ সাধারণ গুণনীয়ক, যেটা সবথেকে কম থাকবে সেটা।
গসাগু
গরিষ্ঠ সাধারণ গুণনীয়ক।
গুণনীয়ক না গুণিতক?
গুণিতক স্যার।
আচ্ছা, আমরা 15 আর 30 এর মধ্যে যদি গসাগু করি কত পাবো?
স্যার 15।
15 আর 35 এর মধ্যে যদি গসাগু করি?
15 আর 35, তাহলে স্যার 5 পাবো স্যার।
ওকে, 15 45?
3 আর 5 স্যার।
15 45 3 আর 5 পাবো
স্যার 15 স্যার। 15 স্যার, 15 পাবো স্যার। 3 5 15।
So we can define the mode size by taking the Gaussian or common greater common factor. Okay, greater common factor of the terms. So here 60 degree is fixed because it comes from 3 phase. So if it is 3 phase, then we have 6 switches, and if there is a 6 switches, we have to divide 360 degree divide by 6, then 60 degree is fixed. And to understand the mode size, we need and to find the mode size, we need to find the value of GCM, or বাংলা যদি বলি গসাগু বের করতে হবে 60 ডিগ্রি এবং আমার কন্ডাকশনের মধ্যে। ওকে, তাহলে এখন 60 degree and 180 degree, what is the value of GCM or গসাগু?
স্যার 60 ডিগ্রি।
60।
গুড, তাহলে 150 এবং 60 এর মধ্যে কত হবে গসাগু?
30 ডিগ্রি।
গুড, তাহলে এখন আরেকটু পড়া দিয়ে ফেলাই। 135 এবং 60 এর মধ্যে কত হবে গসাগু GCM? 135 and 60, in between 135. Good. So for the first calculation, the mode size will be 60 degree, For the second calculation, the mode size will be 30 degree, and for the third calculation, the mode size will be 15 degree. Okay. So in the first size, we have mode size of 60 degree. Okay. So we need 6 modes to complete the cycle. Okay. Is it understandable? 360 degree is a complete cycle. Okay. So each mode is 60 degree. So 6 modes are required to complete the cycle. Okay. In the second case, we have 30 degree mode size. So we need 360 degree divided by 30 degree and 12 modes.
12 mode.
Good. Excellent. And for the third case, 15 degree mode size. So we require 24 modes. Okay. If the mode size is 15 degree, then we require 24 modes to complete the cycle. Is it clear up to this point?
Yes, sir.
Okay. If it is clear, then we can move forward. What about the weather condition in your place? Is it cold or not so cold? So for Q1, we can write here. For Q2, can write here. Just only consider the timing diagram. Forget about the amplitude. Since this board is very small, only a A4 size paper, I cannot make a big change, a big picture. I cannot make a big picture in here, like a large board in the classroom. So two will be here, 3 will be here, 4 will be here, 5 will be here. No, it's much more better. Okay, so we'll define also the number of modes, mode number. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9. Okay. So what will be the output? Okay, let's start with the circuit. Do you find any difficulties to understand? Please let me know.
স্যার এটা কোনটা জানা করলেন স্যার 6180 না স্যার 6150 স্যার
6180. We are working on 180 degree conduction. So the mode size actually, sorry, why it becomes straight? Okay. So, could you please give me some idea about the which switches are on in the mode number 1?
1, 2, 3.
No. Where is
No.
1, 2, 3? Mode numbers are written in the blue. These are the mode
আমাদের
numbers.
স্যার এখানে মোড সাইজ তো স্যার 6 ডিগ্রি স্যার তাহলে 1 হওয়ার কথা স্যার 15
And
1, 5, 6.
জি স্যার 156
excellent, excellent, excellent. It's very good. The mode number 1, 1, 5 and 6 are on. Okay. Now we'll look to the circuit. If switch 1 is on, switch 1 is on, switch 5 is on, and switch 6 is on. Okay, so what will happen? 1 is on, 5 is on, and 6 is on. So we can make the circuit in a different way. So we are drawing the V in, we are drawing two switches. We are drawing So switch number 1, and if we count this point actually here, this one. Okay, is it understandable with you? And switch number 5 is here. So the point A is here, point C is here, and in neutral point is here. So this is the neutral point, is actually here. Is it okay? So
Yes, sir.
the point B is here, and from point B the switch 6 is here. Can you understand the circuit? This is the mode 1 equivalent circuit. Okay, or we can
Sir,
call it equivalent circuit for mode 1.
স্যার 6 নাম্বারের সুইচটা কিভাবে হলো স্যার?
Okay, here from 1 current is flowing in this direction. Okay, so this is the negative. Oops, sorry. In this direction, current is going in this direction. From switch 5, current is flowing in this direction, and current is flowing in this direction. So here current will flow in this direction, the switch is closed in this direction, and the negative terminal will go from this direction. Okay, please
Okay,
follow the orange line. Is it okay?
yes sir.
Enter from 1 and 5 and we'll go to back to the source negative through point B and 6. Okay, so do you agree with me? So
Yes, sir.
Yes sir.
since we will use a balanced load with a 3-phase inverter, what can we say? We can say there that the impedance Z will be same. Okay, since we'll use a balanced load with the inverter, the 3Z will be same. So what will be the output voltage? What will be the output voltage? Okay, this is V in. So what will be the output voltage of VAN? What will be the output voltage of VBN? What will be the output voltage of VCN? VAN means the voltage in this point, between these 2 points. VCN means voltage in between these 2 points. VBN means voltage in between these 2 points. Okay, so do you have any question regarding these points? What is the value of VAN? What is
Sir,
the
VA
value of
minus 0, sir.
Huh?
Sir,
No,
VA
no, no,
minus 0
no,
হবে
no,
না
no,
স্যার?
no, 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 no. I am giving you the clue to find the value. Okay, I am giving you some old school topic. This is 10 ohm, this is 10 ohm, this is 10 ohm. Okay, and this is 15 volt. Okay, do you find similarity between these two circuits?
Yes, sir.
Yes, sir.
Okay, so if it is like this, what will be the value of this voltage and what will be the value of this volt? Oh, sorry. So how do you how will you find these two voltages? The upper 10 ohm resistance are in parallel. So what will be the value?
5.
5.
5, sir.
What will be the resistance or total resistance?
10 to 15, sir. 15 to
15.
15,
So
1
what will be the
ampere current,
current?
sir. 1 ampere.
Good. So if it is 1 ampere, then two resistance of 10 ohm will divide the 1 ampere. So 0.5 ampere current will flow from here, and the 0.5 will go through this here. Okay, do you agree?
Yes, sir.
Current division rule.
Yes, sir.
So what will be the voltage? 10 ohm into 0.5 and 20 ohm into 0.5. Actually, the voltage is 5 volt.
5.
And this one is actually 10 volts.
10 volt.
This is 5 and this is 10. Do you agree?
Yes, sir.
We can do it in another fashion. How can we do it? We can divide use the voltage division rule. We can use the voltage division rule. Okay, I'm just writing the voltage division rule here. If we use the voltage division rule, then we can say that VAN, if we mark with this point A and this point as a N, this is N and this is A. So VAN we can write in this fashion. The parallel resistance we can say 5 ohms and the total resistance actually 15 ohms gun 3 volts. Okay, so we can write 5 volts. Can you recall for using KVL and KCL we have defined those voltage division rule or current division rule in our KCL KVL DC circuits. Okay, is it okay with you?
Yes, sir.
Okay, now we can proceed. What will be the output voltage? So I am deleting everything. So only few students are actually replying this points. I'm not sure whether others are understanding or not, but you are free to ask any question, and I will suggest you to read inverter topics tonight. Okay. So if we just want to draw the value of AN for the first mode, so what will be the value? VAN will be 1/3 of V in. Is it okay with you? We have seen.
Yes, sir.
Yes, sir.
Okay, so if it is 1/3, we can write in here with a value. This is VAN. So what will the value of VBN?
স্যার 1/3 কিভাবে হলো একটু বলবেন স্যার, আমার ইলেকট্রিসিটি চলে গেছিল স্যার।
Oh, 1/3. If you can see that from the just from the previous circuit, the resistance circuit, using that analogy, we can say that VAN will be the 1/3 of V in. খেয়াল করে দেখেছো আগের বার কি ছিল?
জি স্যার।
15 ভোল্ট
জি
ইনপুট
স্যার,
দিচ্ছিল,
আগের সার্কিটে
ছিল 5, 3 ভাগের 1 ভাগ ছিল।
5 ভোল্ট পাইছিলাম। জি স্যার, 1/3। জি স্যার।
ঠিক ওই এটা ব্যবহার করেই সূত্রটাই ব্যবহার করে আমরা যদি ভ্যালুগুলো বের করি তাহলে ভিএন হচ্ছে 3 ভাগের 1 ভাগ। আর ভিবিএন হবে
ইম্পিডেন্স সেন্সর। জি স্যার, বুঝতে পারছি
দুই
স্যার।
ভাগ, কিন্তু ভিবিএন, তাহলে বিএন যদি বলি তাহলে এটা হয়ে যাবে মাইনাস সাইন দিয়ে। বোঝা গেছে? কারণ কেভিএলটা নিয়ে আমরা এইভাবে এই লুপে, তাহলে এনবি যখন বলবো তখন এটা হচ্ছে পজিটিভ, আর বিএন যখন বলবো তখন সেটা নেগেটিভ। ওকে, so VBN will be negative. So in the second mode, what will be the circuit? Which switches are open on?
স্যার 1, 2 and 6।
Good. The second mode, 1, 2 and 6 are on. So the circuit will be a little bit different. So shall I?
স্যার আমরা সিএন নিব না স্যার, এখানে স্যার এএন নিছি, বিএন নিছি, সিএন স্যার।
CN we can
BCN.
take it, but first of all, since there is a space is not so large, and from the very beginning we'll understand only the AN and BN, and then we will find AB. And if it is clear with us, then we can think about AN, BN, CN, and we can take AB, BC, CA. Okay, you can take if you want to take it. Okay, let's have that value. So the CN is also positive 1/3.
স্যার বিএনটা যে নেগেটিভ হলো আরেকবার বলবেন স্যার।
শিওর। এখানে খেয়াল করে দেখো, আমরা যদি কেভিএল নেই সার্কিটটার মধ্যে, তাহলে আসলে আমাদের ড্রপ কি এখানে, সরি আমি ডিফারেন্ট কালার দিয়ে ড্র করি, এখানে পজিটিভ, এটা নেগেটিভ, আবার এখানে পজিটিভ, এখানে নেগেটিভ। আমরা যখন কেভিএল নেই একটা সার্কিটে, মনে আছে এভাবে আমরা কেভিএল নেই?
জি স্যার।
ওকে, তাহলে যদি আমার এখানে পজিটিভ চিন্তা করে এখানে নেগেটিভ চিন্তা করে ভোল্টেজ মেজার করে, তাহলে এটা পজিটিভ পাচ্ছি। কিন্তু যদি পোলারিটিটা চেঞ্জ করে ফেলি লিডের, তাহলে কি হয় আসলে এই পয়েন্ট থেকে এই পয়েন্টে যদি ভোল্টেজ দেখি তাহলে নেগেটিভ দেখবো না? মাল্টিমিটার কখনো ব্যবহার করেছো?
জি স্যার, করেছি স্যার।
যখন পজিটিভ থাকে যদি লিডগুলো উল্টায় দিই তখন এটা নেগেটিভ হয়ে যায় না?
জি স্যার।
Actually these things we can see in the circuit also.
জি স্যার।
Okay, এই পর্যন্ত কারো কোনো কোশ্চেন আছে? Do you have any question? So in the mode 2
No, sir.
we have switch 1, switch 2 and switch 6. 1, 2 and 6. So the new circuit will be in this fashion.
স্যার 10টা বেজে গেছে আমার পরীক্ষা।
জি স্যার, আমাদের এক্সাম টাইম শুরু হয়ে গেছে।
আমি তো ছাড়ি নাই এসে, ছাড়লে তো তারপর শুরু হবে, আমি এখন ছাড়বো তাহলে। থ্যাংক ইউ। So from in the next class we'll start with mode 2. Okay, so
Okay,
you'll get time from 5:10. Okay, and তোমাদের 10:05 পরীক্ষা শুরু হবে। হ্যাঁ, তোমরা 10:25 পর্যন্ত পরীক্ষার অ্যান্সার স্ক্রিপ্ট যা করতে পারবা 10:30টার মধ্যে তোমাকে অবশ্যই এলএমএস এ আপডেট দিতে হবে। ওকে, so I'm stopping the recording.